Hi, welcome to this Die Designer video tutorial. For this video, we are going to look at Misumi stripper bolts. In fact, the Misumi SBTN style stripper bolt. So it's up in the components menu. Scroll down to Misumi stripper bolts, and it brings up the dialog box. To run you through this, through the options, we have our different diameters, 10 millimeters, and then since all this Misumi stuff is in millimeters, I do have the inch conversion in parentheses if you're designing in a inch design rather than a metric design. We have our lengths. This length list is based on the diameter. So as you see it changes when appropriate for the different diameters. We have our views, our plan view, our X-ray view, and our profile view. If you'll notice in the profile view, it'll show you insertion point 1. So when prompted, that's the insertion point of the stripper bolt. And then insertion point 2 is the top of the socket head cap screw. We also have a little bit of data, the catalog number, and then just also the socket head cap screw that's used with these. Just a note, this SBTN number, catalog number, includes the stripper bolt, so when you order it, it'll put it in the bill of materials. It does come with the stripper bolt, or it does come with the socket head cap screw. So you'll see this for this 20 millimeter diameter, it's an M10. For the 16, it's an M8. For the 13, it's an M6. And for the 10 millimeter, it's an M5. Also for the help, click the help button, and it brings you up a description. The command line, if you use the command line, which is usually quicker than going up to the menu and selecting it from the components, but it can take a while to get all these SBTNs and all the other shortcut numbers, shortcuts into your brain. The menu location and the intelligence. It has the bill of materials intelligence, so when you put these components in the plan views, and then you go to leader balloon them, you will, when prompted, select to attach during the leader ballooning command, and yeah, that way it'll populate the bill of materials with it. It does do an object transform. It transforms into a drilled hole of the pin diameter plus either 1 millimeter or approximately 1/32 oversize, and that's depending on the current drawing units, whether it's a metric or a inch drawing units. Okay, so since it only transforms into a drilled hole, what if it's a counter bore or whatever? Well, I'll try to explain that. If the stripper bolts are in a counterbored hole instead of a drilled hole, simply create a counterbored drilled hole, or CR. And if you go up to hole types, there will be an option for counterbored drilled holes. And then you will, when prompted for the diameter and the head diameter and the depth of the counter bore, fill that in. And then again, go back up to transform and find the search and replace, or SR, and search and replace all instances of that. And I'll show you this. I know I'm probably a little confusing speaking it, but I will show you this. And then it also has the Die Designer Touch command, which is mouse activated with a specific button. So you can just once you draw a plan view of one of these stripper bolts in, you can click on it and it bypasses the dialog box and you can just put additional components in. Notes. These stripper bolts are metric and include a metric socket head cap screw. That metric socket head cap screw is listed in the catalog number code for these components that goes into this above bill of materials. To transform this component for the socket head cap screw, which is usually in the stripper plate, use the socket head cap screw command, and that would be up in the fasteners menu, and SH from the command line. Select the correct size in M6 and M10 and M8, whatever it would be, the correct view, place that socket head cap screw in, then do a transform. And I'll show you that too. That's TR, and that's up in the transform menu. And then again, I use this search and replace a lot. Then search and replace all instances of it. We also click this button to watch this YouTube video. And yeah, let's get started here. This is a top view with a side view of a current design that I'm working on. So some of this I already know what these sizes are going to be. So I'm going to go with the 16 millimeter diameter with this 35 millimeter length, and it's using the M8 socket head cap screw. So let's put this in over in this cross section, and once again notice insertion point 1 and insertion point 2. So insertion point, we are going to put it between, and we'll put it on the back side of the stripper and between this line. Now it's prompting us for the top of the socket head cap screw, and let's snap to perpendicular, and it draws it in. Now, like I said, I've already done this, so I know what size I want. I also know that I want this up into the stripper 125 thou, so I get the correct stripper travel of 200 thousandths. I'm going to do a little bit of cleanup. I am going to put the unified screw cap and the spring in this cross section too. So components, screw caps and plugs, or UM. We'll put the profile view in an 1 1/8 thread. Drop it in. We are going to now put the spring in, components, dice springs. We're going to use a 1 inch. It doesn't matter right now because the intelligence is in the plan view and that's already been done. So we don't even have to spec a length here in this profile view. So I'll just click OK, follow the prompts, and draw the spring in. I'm going to do a little bit of cleanup here. Line, 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 offset and erase, change layer, trim, trim. Yeah, and there you have it. So let's put a couple notes in. V for travel. Remove last. Let's put a note in for this, the depth of this oblong slot that's already drawn in the plan view. Typical. Okay, so now we have it in the plan view. We know our sizes are right. So again, let's go over to our plan view now. We know our 35 length was correct. We knew our 16 millimeter body diameter was correct. And again, just keep in mind this is an M8 socket head cap screw. And let's put that in. So I put it in out of position, but I'll just show you the touch command now. So I start the touch command by just hovering over it, clicking the appropriate mouse button, and I can put another one in. Okay, so I'm just going to copy these guys into the center of all these spring and unified screw plug assemblies. Yeah, and they're all in. Now to show you a little bit of the intelligence. And I am just going to balloon this assembly here. I am not going to leader balloon the whole top view of this job. It just be too time consuming, and I want to keep this video as short as possible. So we'll go up to split leader balloons. We'll start with balloon number 1. Snap to the center. And draws the balloon. And now if you see the prompt, select object to link or enter. Well, we want to link an object, so we're not going to hit enter. So I'll select that stripper bolt. Let's get the rest of that assembly. Balloon 2, V for vertical. And let's select the spring. Balloon 3, vertical. And let's select the unified. So yeah, our ballooning's done. At least for this video, it's done. We're going to go up to Design Aids, Bill of Materials, or BM. And you know what? Let me scroll down here real quick because this happens so quick. Bill of Materials. And yeah, there you go. There's our Misumi Detail 1, 10 required stripper bolt with the catalog numbers. The spring behind it, 10 required, and then the unified screw cap. Yeah, so pretty quick, pretty simple, pretty intuitive. Now to show you, I've showed you the touch command intelligence. I've shown you the bill of materials. I'm going to show you now the object transform. So let me freeze a few things. If I were going to detail this out, I have 3 plates on the top. I have my stripper, I have my punch yoke or punch pad, and I have my punch pad backup plate, and actually then I have my die set too. For this instance, I would transform all of this stuff for the individual plates. It happens real quick, but it will take a few minutes, so I am going to just copy this out and show you what I would do. For the punch pad, which is just the drilled hole through, which is the default that an object transforms to, and let's make 3 instances of this. I would just go object transform, and it transforms into a drilled hole. Now for the head diameter hole, I would take a look at my unified 1-inch 045 ID. I know it's a 1-inch spring, and I just measured this, and it's under 1 inch, so we are going to go to hole types, drilled holes, 1 inch. I could do, well, I don't want to confuse you guys. All right, if you remember, this was a M8 socket head cap screw. So what I would do to transform for the stripper, where it gets drilled and counterbored for that socket head cap screw, I would go to fasteners and threads, scroll down to socket head cap screws, or SH from the command line. And as you can see, it's already ready with my M8 socket head. It's in the top view. Click OK. And now I would go to transform, and we're looking at fastener transform, and we're going to transform it to a counterbore, or TR. And we will accept, it disappeared, but now it's prompting me for a depth, and you can see the 9mm depth. We will accept that. And yeah, so instead of doing the search and replace throughout this whole thing, I'll just make a few instances of these. So we had 5 on the okay. So for the stripper, I would do my transform, or my search and replace. Snap to the center, select one, then select them all, and it transformed them into that socket head cap screw. For our backup plate, it had a 1-inch drilled hole. Once again, search and replace, snap to the center, select one instance, now select all instances. Now for just our drilled hole for the head diameter, again, search and replace, snap to the center, select the item, and then select all instances of the item, and they're transformed. So these would all, these holes here would all be in the punch pad transformed. These would all be in the punch pad backup plate, and these would all be in the stripper. I'm keeping them isolated just because there's so much other stuff going on here, and I'm trying to keep this video short. I would then use the whole table command, or HD, and I would use the select option. So I would select these whole plates with all the other stuff that was transformed and searched and replaced. I would do it all, but again, for this video, to keep it short, I'm just dealing with these components. So it labeled them all. You can see we got the A, the B, and the C, and we got the A, the B, and the C in the whole data. So yeah, kind of cool. Hope you followed this. I will be doing some future videos where I basically design a die. It'll be in a series of video segments just to keep them short. I do have something like that earlier, but I'm going to completely redo those older videos. So yeah, I hope you enjoyed this. Stay tuned for some more videos. I have a video coming up with the visual block library, and this is really neat. But just to give you a teaser, you can create your own library of components based on customer, based on components. And you can add intelligence to them. You can add transform information to them. You can add whole chart information, catalog item, or a group of catalog items. So it's really kind of neat. You got different vendors that you can put information to. So anyways, I won't go too far into that, but that should be coming up here pretty quick. So once again, thanks for watching, and have a great day.